Now, there are various types of recurrent neural networks as well, and here are a few. So there is one-to-one, where a good example of this is image classification. You give it an input image, and then it classifies and gives you an output of what that image belongs to, or what class the image belongs to. Then there is one-to-many, where an application here might be music generation or image captioning, where you give it a piece of text or an image again, and then it results in a few outputs. If it's image captioning, you have a sentence describing what the image contains, or if it is music generation, you get some music. Next, we have many to one, where you give it many inputs. So this can be a paragraph of text or a review for sentiment analysis, and then you just get one output out of it saying if it's positive or negative or neutral sentiment. Next, we have many to many, and we have two variants of many to many. So the first one is machine translation, and then the other one is sort of text summarization. And here we have many inputs, and with translation we can translate and get many outputs out of it as well. So these are some of the types of recurrent neural networks. But one common theme across all of these is that there is usually an encoder and then there is a decoder. So if we take an example of translation, we have an input text over here, which gets encoded, and then we do the processing. And finally, there is a decoder step where we expand the output and then give the output. So think of this encoder as zipping some files and the decoder as unzipping those files. And this architecture of encoder decoder is actually what sets standards for today's large language models. Now, quickly, we'll go over some of the disadvantages of RNNs as well. So the first big disadvantage is it can't be trained in parallel. So training becomes really costly and takes a long time. So RNNs are not able to use the parallel processing within multiple cores that a computer offers. So next, RNN also suffers from catastrophic forgetting. So even though they had memory for very long text, they do not have capabilities to keep this information. So that is what is long range dependency is missing within RNN. So you can go after maybe the previous 3 or 4 words, but not for long text. Next, there is also sequential processing, which becomes a disadvantage because it's not able to take advantage of the multiple cores for parallel processing, and scaling to large data sets becomes a really big problem because it's not able to parallelize, and we're not able to train this in serial because it takes too long. Now, RNNs are very powerful, but they suffer from this vanishing gradient problem, where they are good for storing 3 to 4 instances of past iterations, or if it is text, then think of it as the 3 or 4 words in the past. And this causes an issue, which is the larger number of instances don't provide good results. So we don't use regular RNNs. So if you're working on a text summarization task, and if the summary is only based on the previous 3 or 4 words that it encounters, then that's not a good summary, because for summarizing an entire page or a paragraph, you need to look at the overall context of where each data is coming from. So instead of RNNs, we look at the next version, which is the long short-term networks. And this was built to handle the exploding and vanishing gradient problems.